Hey, let's talk about dilations, which I like because it's kind of artsy. It's pretty much 1-point perspective art. Have you ever done that before? You ever done that before? Look, I got this old book. It's an old book. But this is pretty much what a dilate. This is a dilation right here. These are all dilations. It's a way of enlarging an object or decreasing an object's size. All right, and that's what we're gonna do today. So let's go get it. It's okay. You can be silly with me today. It's all right. We can be silly and intelligent at the same time. All right. Well, that's a beautiful introduction, Mr. Miller. Would you please start with a definition? I'd love to. Let me tell you, I'd love to. Let's write a definition. All right, so a dilation is a transformation that changes the size of an object, but it preserves the shape of an object. So it's going to allow us to enlarge and decrease the size of the object, all right? And it creates geometrically similar shapes, hence preserving the shape, right? Geometrically similar shape. Kind of fits right into the unit you're probably working on right now about geometric similarity. Now, this is probably going to be the fourth transformation you've seen. Here's the first three. So the first three that you learn are translations, reflections, and rotations. They're both rigid. All three are rigid transformations. Let me hear you say it loud. You're supposed to say preserve size and shape, but that's only if you've seen my earlier videos, I suppose. And now we got dilations. Notice it also preserves the shape, but it's going to change the size, so it doesn't preserve the size. And it's also going to preserve orientation. It's not going to be in the same, it's just going to kind of do a translation a little bit because it's going to slide out a little bit, but it's going to get bigger, but it's not going to rotate at all. And it's not going to reflect. All right? Well, with that, let me get started with the first shape we're going to dilate, which is a rectangle. So this first point here, is going to be called a center of the dilation. Okay, so that's the center of the dilation here. And let me draw the two rectangles now. Okay, so let's start. First thing we're going to do is this one's going to be an enlargement. We're going to do a dilation with a scale factor of 2. And in this rectangle, we will do a reduction. We'll make it smaller with a scale factor of 1/2. All right, so the first thing you need to do is you need to draw your lines, your dilation lines. So what you're going to do is you're going to draw a line from the center of the dilation through each point that you're gonna dilate, okay? So I'm gonna draw those lines right now. All right, so here's what we're gonna do. And I'll go slow on the first one, and then I'll pick up the pace a little bit. So what we're gonna say is we're gonna measure. I actually had to change, I don't know if you noticed when it was zooming there, I changed the point. I had to get a little closer because I needed to make sure I had enough room to create the larger object. So here's what I'm going to do. I'm going to measure AW, the distance from A to W. So let's do that right now. It's about 20. It's about 20 centimeters. So what that means, how you do the dilation is you've got to double the length. The new point should be twice the distance from the center of dilation as the old point if you're using a scale factor of 2. So now I'm going to measure out 40 and put a new point. I'm going to measure out 40 centimeters. So general convention says you put a little prime. So it's A prime. So I know here that A prime W should be 40. So I'm going to do that exact same procedure, but for the other 3 points. I'm going to measure the distance, then I'm going to double it. Okay? All right, give me a second. All right, so I didn't even draw this dilation line long enough, but I got to B prime. I better check to make sure I'm still on the camera. I am, perfect. Okay, so you can kind of see it's happening, right? We're kind of sliding along these dilation lines. Now what I need to do is just connect my points and create my dilated rectangle. Let's do it. All right. All right, we got this drawn. Looks pretty cool, right? I like it. They're geometrically similar, i.e. the ratio of the height to the width is going to be the exact same on both. A scale factor exists between the two, which, by the way, is 2 based on the dilation I did. Some new vocab. The original shape prior to dilation is called the pre-image, and the shape after the dilation is called the image. And that's it. Beautifully done. Okay? Now we could do a little art on it if we want. We can make it look like it's like a box. Like if you're looking under a box that you're lifting up. Like this box, right? We can make it kind of look like that if we want. That would be kind of cool. We can make it look like a skyscraper. And looking down on a skyscraper. Yeah, let me just take a second to make it look a little cooler. And what I'm going to do is I'm just going to erase the lines that you couldn't visually see. All right? The hidden lines. Let me do that. I don't know. There you go. Looks kind of cool. It looks like you're looking under a box. So now we'll do the same thing. We'll do a dilation on the bottom one. And we're going to use a scale factor of 1/2. So we're going to reduce the size of it. So what's the first thing I'm going to do when I make my dilation? Well, I'm going to define the points that I want to dilate, that I'm going to use to redraw the object. And then I'm going to draw my lines of dilation right through those points. That's what you're going to do, Mr. Miller. I believe in you. Thank you. Thank you for believing in me. All right, let me do that right now. All right, so what I got to do is I have to measure what's going to be the distance from F to W. I got to cut that distance in half to find my new F. All right, so let's look at it. Let's just do this one here live. That's 27. So I'm going to cut that in half. I need to be at 13.5, right? So you should need to be at about 13.5 centimeters. So let me go in, 13.5. That's my new F prime. Perfect. I know. Hey, I didn't say it was like the most difficult thing in the world. It's actually such a beautiful thing. It's artistic. Let me do that 4 more times. Ta-da! So now we reduce the size. It's going to be 1/4 the size, right? The area is 1/4 because I used a scale factor of 1/2. Final little thing, we can try to erase the lines that you wouldn't be able to see normally. So let's see, we got that line we can see, but we won't see it after that. Nope, not seeing that line. We are not going to see that line, not going to see that line, nothing behind it. All right, and that should give it kind of the feel of looking down at a box, here. Not totally perfect. Not perfectly executed there by me, but pretty close. Pretty close. There it is. It looks kind of like you're looking down at a box. Okay, so that's how you use geometry to do a dilation. There's also algebra to do a dilation on a coordinate plane. I do need to show you that. That's the last thing we're going to look at. It's super fun. You're going to like it. But let me just get prepared by erasing these beautiful dilations. All right. Okay, so this is our triangle that we're going to dilate. First of all, you're probably saying like, damn, Mr. Miller's like a wizard. He just put that piece of like paper on it. He didn't even use tape. How is it staying? Dude didn't even use tape. How is it staying up there? All right, so I'm going to use matrix notation. Okay, so I just put the points in a matrix. You don't have to do that. You could put the points like more standard, like this. But as I said in my other geometry videos, I prefer to use matrix notation. I think it's a lot more fun, so I'm going to stick with it here. All right, so what we're going to do, if you want to do a scale factor 2, and this matters, this does matter, that the center of dilation is at the origin. At the origin, people, there it is. As long as the center of dilation is at the origin, all you have to do is multiply each coordinate by whatever you're going to dilate. So you want to dilate by 2, multiply by 2. You're going to have a scale factor of a third, multiply everything by a third. You're going to have a scale factor of 11. I don't know what you would do. You'd multiply by 11. So, switching colors here. What we're going to do, I'm going to make sure I got enough room. So we're going to times 2 on this. So let's see, we're going to still have our x and our y. So every x value gets multiplied by 2. Let's just go. 4, negative 2, 10. Every y value multiplied by 2. 2, 6, 8. Let's give it their primes. Let's remember one other thing. And just like that, you're done. Beautiful. It's beautiful. It's beautiful. But I don't really believe you, Mr. Miller. Are you sure that's a dilation? Well, I'm just going to do this once, but let's graph these points and see what it looks like. And there you go. See? Dilation. Perfect. So last example, I want you to finally step in and maybe try something on your own here. Or I'll give you one more. Let's show you. All right. Scale factor is a half. So this will be a reduction. Just figure out the new coordinate points and you're done. Hit pause. Pause. Unpause. Let's go. So, that's the beautiful thing about matrix notation. I know, Mr. Miller, yet another beautiful thing. Is kind of the ease of the whole thing. So I'm going to, hopefully I'm not running out of room here, but let's just do that here and just hope that you can see that side. So multiply everything by positive a half, right? So I'm at negative 6. I was at negative 6, negative 3. 0 times a half is 0. We've got 4, 2, minus 1. Those are your new coordinate points. Graph them if you feel like it. I like dilations. I like it. I think it's fun. I like the arts. I like doing it geometrically because it looks really pretty to me. It's kind of this cool art thing. And algebraically, it's pretty slick. Anyways, it's a beautiful day. I'm proud of you for putting in effort. I am proud of you. I'm proud of you. Mr. Miller's proud of you. All right. Take care of yourself. And I hope this video found you in a beautiful place. And take care. All right.